All right, here we're looking at the integral of x cubed plus 6x squared plus 3x plus 6 over x cubed plus 2x squared. That's a rational function. So the first step here is, well, the degree of the numerator is 3. The degree of the denominator is 3. So you want to perform long division to rewrite this integrand. So go ahead and hit pause now, perform long division, and rewrite that integrand where the numerator is less than the denominator as far as degree, and there's going to be a polynomial term in front. All right, go ahead and hit pause now and do the long division on your own. All right, I can go ahead and do this by hand with a pen. And I've got here x cubed plus 6x squared plus 3x. And then I have a plus 6 at the end. And I'm going to divide into that x cubed plus 2x squared. So notice that here I've got an x cubed, an x squared, an x, and a constant term. If I were missing powers of x, I'd have to put zeros or placeholders, just like you do in long division. So x cubed goes in x cubed once, so the first is going to be a 1. 1 times x cubed is x cubed. 1 times 2x squared is 2x squared. But again, just like in long division you did in grade school, you have to subtract. And that's going to be a 0, of course, by design, and this is going to be a 4x squared. And then I'm going to drop down the 3x, and drop down the 6. So now, notice that the degree here is 2, and the divisor has degree 3. So this is the quotient of 1, and this here is the remainder. That's the remainder. Okay, that's the divisor. And that's called the quotient. So when you do long division, p of x over q of x, this is going to be the quotient plus the remainder over the divisor. This is even true when we do, grade school long division, like 365 divided by 25. You're going to have a quotient and a remainder, and you're going to have a divisor. So rewriting that integrand, I'm going to get that's equal to, so over here, this is equivalent to 1 plus the remainder, which was 4x squared plus 3x plus 6 all over. I'm going to factor that. So the denominator here I can factor out an x squared. And I'm going to have an x plus 2 left over. Dx. Okay. So notice here, this first part, trivial to integrate. When I integrate 1, I'm going to get x. Here I've got a numerator. The denominator is degree 3. That's degree 2. This is degree 3 because that's an x plus 2 to the first power. Notice this is a repeated linear factor. Okay, that's a repeated linear factor. So when I do this, I'm going to rewrite. I'll forget that there's an integration. So I'm going to rewrite 4x squared plus 3x plus 6 over. I'll just to realize that this is a linear factor. I know this is, doing the obvious, but x squared is x minus 0 squared. That means the denominator has 0, the value is 0, has a 0 of minus 2, right? x minus 2. Okay. Of course, you don't have to write that. I'm just showing that the zeros of the denominators are turned into factors. So this is going to be equal to a, right, over x plus b over x squared. I mean, you could write x minus 0 and x minus 0 squared, but that's what you get, plus c over x plus 2. All right, so all I'm focusing on is this part here. Okay, so now, if we get a common denominator here, so I'm going to have to multiply a by x and then x plus 2. I'll multiply b by just x plus 2, and I'll have to multiply c by an x squared. So if I do this, so I get 4x squared plus 3x plus 6 is going to equal a times x plus 2 plus b times x plus 2. Oops, writing 2 backwards. It's backwards day. And plus c times x squared. Okay. Multiplying these all out, get ax squared plus 2ax plus bx plus 2b plus cx squared. So collecting all of the like powers of x, I get a plus c times x squared plus 2a plus b, right, 2a plus b, x, and then plus 2b. And that's got to equal 4x squared plus 3x plus 6. Okay, so now if I look at this, I'm going to move this up here. That means a plus c has to equal 4 because x squared, that means this coefficient has to equal 4. So here I'll write that. A plus c must equal 4. And 2a plus b equals 3. 2a plus b equal 3. And finally 2b equals 6. So that implies that b is 3. So we'll put that here. So if b is 3, then that means 2a plus 3 equaling 3. Well, I'll subtract 3 from both sides. That means 2a equals 0, which means that a equals 0. Plugging a equals 0 here, that easily implies that c is 4. 0 plus c equaling 4 implies that c equals 4. So now I can rewrite that original integrand. So I've got a is 0, c is 4, b is 3. So this is 0, this is 3 here, b is 3, and c is 4. Okay. All right, so here's our original integral. When we did long division, we got a 1, and then we got this leftover business here. but we got the coefficients to be 0, 3, and 4, so there really isn't a term with 1 over x in it. I did put 0 over x. B was 3, so that's 3 over x squared. C was 4, so that's 4 over x plus 2. Rewriting this so I can apply the power rule, that's 3 times x to the minus 2 plus 4 over x plus 2. So integrating this is trivial. This becomes an x. Add an exponent to this of 1, so it's going to be x to the minus 1, but divided by minus 1, so it'd be minus 3 over x. This is going to be 4 natural log x plus 2, and then there's the arbitrary constant. So writing it out, I have the x, there's the minus 3 over x, plus 4 natural log x plus 2, and plus c. All right, that concludes the last example from the 3.4 and looking at partial fraction decomposition.